Okay guys, I'm gonna do a quick video here on the real number system, some factorization, and also some expand and simplify questions so that we can all get geared up for paper one, which is coming up for some of you in some of the provinces, coming up Friday already, and paper two will do shortly after I've been able to do a large amount of paper one. So let's turn to our first question. The first question says, given the square root of the cube root of -8, the square root of -5, and the square root of 3, which of the numbers is 1.1.1 non-real? Right, so guys, I hope we understand what non-real numbers are. Non-real numbers are numbers that are basically negative numbers written under a even root. Okay, so non-real numbers that are negative and are written under a even root. So in other words, let's think of a negative number, -5, and let's just say -5 was written under a square root. That would mean that this number is unreal. Or let's think of -3. Now let's say that the fourth root of -4 was written. The fourth root of -3 was written. So the fourth root of -3, this is an even root, so there's a negative number inside, so that would qualify as non-real. So this only applies when there's a negative number inside a even root, right? So non-real numbers are numbers that are negative and are written under a even root. So if, for instance, we had a odd root of a negative number, this is not non-real. Okay, so I hope that makes it clear for all of us what distinguishes a real number and a non-real number as opposed to a real number. So this would be a real number because it's an odd number, odd root with a negative number inside. Okay, so if you put this in our calculator, we'll actually find that you will get an actual value which qualifies as a real number. And for your real numbers, your real number system consists of rational numbers, okay, and irrational numbers. Okay, so hopefully that makes a lot of sense for all of us and gives us a bit of direction. So let's come here. Given these 1, 2, 3, which of the numbers is non-real? So it's very clear, guys, that it is the square root of -5 that would qualify as non-real because there's a negative number under a even root. Because remember, this is a square root, and we know that a square root is actually a even root. Okay, typically, if we were to reveal the root there, we would see that indeed it's a square root, okay, which is a 2 that's there, right? And that's an even root. So this would qualify, the square root of -5 is the only one that qualifies as a non-real number. The cube root of -8, on the other hand, is not non-real because we put this in our calculator, we get -2. So this is actually a rational number, okay? Square root of 3, on the other hand, is not a non-real number, it is an irrational number, okay? Okay, so let's move on to 1.1.2. Which of the numbers is irrational? So let's just go back to our definition. Remember, we spoke about the real numbers. So the real number system consists of all the numbers that exist under the sun. So we can categorize them into two. There's rational numbers. These are numbers that can be written in the form a over b, where a and b are actually what? Integers. Now integers are positive and negative whole numbers. Numbers such as 0, 1, 2, 3, -1, -2, these are basically integers. You can go 1, 1, 2, 3, they go up by 1 and decrease by 1. These are integers, okay? And they are symbolized by the letter Z These are integers. So a rational number is a number that can be written in the form of a fraction, where the numerator and the denominator are integers, and the value of the denominator can never, ever be 0. Because when b is actually equal to 0, we know that the fraction is undefined. Okay? So that's our rational numbers. If we look at the decimals of a rational number, we know that decimals of a rational number can either be 1, terminating decimals. Okay, and just to give you an example of terminating, 0.58, stop. It terminates, it stops after the second decimal. 258, stop. 0.881, stop. Okay, so this is rounded off to 2 decimal places. This is rounded off to 1, 2, 3, 4, 5, fifth decimal place. This is rounded off to 3 decimal places. So all rounding offs to a certain decimal place would qualify as a terminating decimal, because it stops at a certain decimal place. That's a terminating decimal. The word terminate means to stop or to end something. Okay, so it comes to an abrupt end. The decimal comes at an abrupt end, whether it's the second decimal place, whether it be the 5th decimal place, whether it be the 3rd decimal place, or any other number of decimal place. As long as our numbers come to a stop, we call them terminating. Then 2, we have another type of decimal when it comes to rational numbers, and that is recurring decimals. Recurring decimals are, as the word suggests, repeating numbers after the comma. They repeat infinitely. So hence we call them infinite recurring decimals, because let's say 1,7. Now we put a dot on the 7 to indicate that the 7 continues indefinitely, forever and ever. Or you can say 1,38. We put a line over the 3 and the 8 to show that the 3 and the 8 repeat. Okay, or we can say 1,707 and you put a dot. Okay, the in between number has no dot. That is to show that basically the 707 repeats infinitely, right? Infinitely. 707. Okay, hopefully that makes sense. Okay, this repetition of 707. Okay, so this is basically what we are talking about when we talk about recurring decimals. Okay, yeah, so these all, like I said, rational numbers are fractions, can be written as a fraction where the numerator and the denominator are integers and where the denominator can never be 0. But then when we look at the decimal numbers, it can either be terminating decimal numbers or recurring decimal numbers. And for the short form of a recurring decimal is usually indicated with a dot on top of the number that repeats. For instance, 1,23, that indicates that only the 3 repeats. So that will be 1,2333333 forever and ever and ever, if you know what I mean. Okay, so this is very important. The line on top of the numbers that repeat, or the dot over the multiple numbers that repeat. Okay, terminating decimals and recurring decimals. Then if we look at irrational numbers are the opposite. Irrational numbers cannot be written as a fraction where the numerator and the denominator are integers and where the denominator cannot be 0. So what we observe with irrational numbers, so instance, if you take the square root of a non-perfect square number, square root of a non-perfect square number. Okay, 3 is a non-perfect square number. Under the square root, what you do get is a non-recurring and non-terminating decimal. So in other words, if you were to represent the decimal place of square root of 3, you'll find that the decimals are non-recurring, meaning they do not repeat, and they are non-terminating, meaning they do not stop. So there's no repetition and there's no end. What you see is that after the comma or the decimal, you find that numbers, they do not repeat, neither do they stop. Okay, That's the special thing about irrational numbers. So if we come here and we were to then say which of the numbers is irrational, the cube root of -8, if you put it in the calculator, you get an answer of -2. Now -2 can be written as -2/1. So this here is a rational number. Okay. Square root of -5, we established that the even root of a negative number is non-real. The square root of 3, if you put this in your calculator, you press SD in your scientific calculator, you get a non-recurring, non-terminating decimal. This is also the square root of a non-perfect square number, so that qualifies as irrational. Okay, so that's part 1 of this video that I wanted to do, 10 minutes or so. And what I'll be doing is in the next part video, I'll be doing 1.2, 1.3, just so that we can be able to extend our knowledge and understanding of the real number system, because that's important.